Hello, everyone, and welcome to today's presentation. I'm Tammy Diedrich, the Managing Editor of IBM Systems Magazine, and I'm the moderator for this event. Today's webinar is sponsored by SUSE and is titled 15 Years of Linux Innovation for IBM SystemZ. Our featured speakers today are Patrick Caroli and Marcus Kraft. Patrick Caroli is the Global Alliance Director at SUSE for IBM. In this role, he's responsible for evaluating, exploring, and developing long-term strategic engagements through the SUSE partnership. He spends a great deal of time working with IBM to match partner technologies with SUSE products and strategy to create strategic business initiatives. Marcus Kraft is a Senior Product Manager at SUSE. In 1994, Marcus joined IBM's engineering team in Böblingen to develop microcode for IBM Model 967X system controllers. Since late 1998, he's worked at SUSE in various roles ranging from support, engineering, and product management. During most of that time, he's been primarily focused on SUSE Linux Enterprise Server for SystemZ. Today, these gentlemen will give you a preview of the next generation SUSE Linux Enterprise operating system. Following the presentation, we'll have a brief Q&A period, so please feel free to enter your questions in the question panel on your screen anytime during the presentation. Now, without further ado, thanks again for joining us today. And Patrick, I'll turn the presentation over to you.
Hey, thanks, Tammy. I appreciate it. First off, I'd like to thank everyone for joining. We've got an incredible attendee list here today, so thank you for that. If you need to contact myself or Marcus, please make note. Our emails are here on the first page, and I think we're probably repeating them somewhere else for your information, but I'll just pause here for a minute and say thank you. And again, I want to announce that we are talking today about SUSE Linux Enterprise Server 12, which is pending release any day now. So that's really exciting. And let's get started. So we've been working with IBM for over 15 years on not just SUSE Linux Enterprise Server for SystemZ, but with a number of IBM products and services. Had to take a minute this morning and think about it. I've only been around since 2008 in this role or capacity, so I've only got about a third of the experience of somebody of Marcus's caliber. But for some reason, I'm talking twice as long, so I apologize for that as well. We'll try to get to Marcus as quickly as we can. First thing I'd like to do is talk a little bit about our product lifecycle. Product lifecycle is really important because it helps our customers understand what to expect from SUSE, and it helps our customers plan properly for their subscription needs. So we do sell our product as a subscription. It is not sold as a license and maintenance. A subscription is very similar to a magazine or a newspaper subscription. As long as you continue to pay for this subscription on either an annual or multi-year basis, you'll continue to receive updates to that magazine or that newspaper. The same is true with Linux. So as long as you continue to keep your subscription up to date, you will get patches and updates. Now, where we are today, which is really exciting, is we're very close to the general availability release of SUSE Linux Enterprise Server 12. We typically have 2 products in our supported lifecycle at all times, so we will be supporting SUSE Linux Enterprise Server 12, and we will continue to support SUSE Linux Enterprise Server 11. The way our support lifecycle model works is we typically release our service packs about every 18 to 24 months, depending on the need or the number of changes that happen inside of that service pack. And we provide our customers 6-month upgrade window to go from Service Pack 1 to Service Pack 2. Once Service Pack 2 is released, that's when that 6-month window starts working. If for some reason you want to stay on a previous version, whether that reason is for a compatibility reason, whether it's for an existing project that's going on, or whether it's for a compliance issue, we do allow you to stay on previous versions, but it's important that you then subscribe to our long-term service pack support program. And this is really important. I'm going to use a real case example of something that we've just all experienced in the past few months. I'm sure everyone's heard about the shell shock bug that came out that was identified a few months ago. If you haven't, you can go and Google shell shock and you'll hear all about it. But what is important here is that when we do bug fixes, we always work first on the current release. So, for example, if we're talking about SUSE Linux Enterprise Server 11 Service Pack 3, the first thing that's going to get patched is that current release. And if customers have an existing subscription and they've got access to the Service Pack 3 channel, but they're running Service Pack 2, sometimes they feel they can go into the Service Pack 3 channel, take that patch and update, and apply it. Well, in this particular case, that wouldn't have worked because there were a number of patches that had been applied between Service Pack 2 and Service Pack 3, and you would have had unresolved dependencies. And this is why long-term Service Pack support is really important, because once we patch our current release, we go back and backport those patches and those fixes into those long-term Service Pack release channels. And that gives you the ability to keep your system maintained and secure, but staying on that existing Service Pack. So again, if you're not current on your patches and updates, we encourage you to find a way to make the time to patch and update your servers. We think a patch customer is a happy customer. If you're not in a position to patch and update your server, reach out to us and we'll talk to you a little bit more about LTSS. So at SUSE Linux, one of the things that makes this possible for patching previous versions and maintaining multiple platforms inside of our product portfolio is the fact that we do build everything off of a common code base. There's tens of thousands of packages out in the open source community, whether it's on SourceForge or GitHub. And we work within those open source communities to bring those projects into our code base. Now, our code base or our code stream typically consists of anywhere from 2,500 to 3,000 product packages. And we select those packages and integrate them together, making sure that we avoid any dependencies that would cause conflict. We also work to maintain the user space to help application compatibility for our ISVs and our customers. We then move this into our build service, and the build service is a unique offering that SUSE brings to the market. The build service allows us to use that single code base and build for the target platform that we want to execute on. In this case, it's SystemZ, and we take into that tool chain the compiler, the libraries, the architectural specific switches for those compilers and libraries, and make those available to the build service, which then takes the output, and that's where we start our quality testing. Now, there's some automated regression testing built into the build service. We also do some manual regression testing, and this is where we also invoke the help of our hardware providers like IBM to do testing on their part. And we do this for months and months before we release a full product like SUSE Linux Enterprise Server 12 or even a Service Pack release. So let's talk a little bit about SUSE Linux Enterprise Server 12. So when we started looking into SUSE Linux Enterprise Server 12, we started asking some questions, and these are questions that customers often ask us. They ask questions about how do I increase my uptime, or how do I avoid downtime? How do I take advantage of all of the great innovation that's happening in the open source market between Service Pack releases? Or how do I really get the most out of my system, and how do I get the most out of my employees who are responsible for the maintenance and the upkeep and the care of those systems? So one of the first things that we did is we started looking at what our requirements are and how do we accelerate innovation. And the first thing we came to the conclusion is that 64-bit is where we are today, and that's where we're going to continue to go in the future. Our kernel is going to be a 64-bit kernel only. You will still be able to execute 32-bit applications because those libraries are available, but that is going to be executed on top of a 64-bit kernel. So it's important that the hardware is 64-bit. We continue to enhance our virtualization portfolio. Inside of SUSE Linux for our other platforms, we include Xen and KVM, but obviously on the SystemZ architecture, we support ZVM. And again, we will continue to support both 64-bit hosts and only 64 and 32-bit guests. From a hybrid from a hybrid computing perspective, we are working to take advantage of processors and graphic processor accelerators because we see that as an emerging technology today that customers and service providers are looking to capitalize on to improve performance. In SUSE, we also have a program called the Solid Driver Program. And the Solid Driver Program is a program that we use to work with our hardware providers and our device manufacturers so that as they release new hardware, they can provide us the drivers and the code, and we can then test those, certify those, and provide those on drivers.suse.com. So we're always able to take advantage of the most recent hardware releases from our partners. Keeping up with innovations and talking about enterprise quality, we are going to release on the 3.12 kernel. The 3.12 kernel is the kernel that we landed on to make this release happen. And this was based on feedback from partners like IBM and other hardware providers who were telling us what their roadmaps look like and what capabilities and features they needed to see inside of their product portfolio to support their customers. Now, the 3.12 kernel or the 3.0 kernel is nothing new to SUSE. SUSE Linux 11 Service Pack 2 was the first release that we had that supported the 3.0 kernel. So we've been doing this for a few years now. We've got a number of years of experience underneath of our belts in supporting the 3.0 Linux kernel. We continue to provide customers choice and flexibility as it relates to operating systems. We've been supporting XFS as a base file system inside of our distribution for over 10 years. We do recommend that XFS is your platform for data. That's really important because XFS can take very large files. It's very robust in that perspective. But we also introduced a few years back BTRFS, or ButterFS as it's called. And ButterFS is a copy-on-write file system. And the purpose of a copy-on-write file system is to give customers the ability to snapshot sections of their file system or the distribution in order to do rollback capabilities. ButterFS is only recommended for the Linux file system and not necessarily for your data. And we'll talk a little bit more about that as we move forward. At SUSE, we have been supporting Linux containers for a number of years, LXC. If you guys are hearing lots and lots of things out in the market today about stuff like Docker, well, containers is something that Docker utilizes. Control groups is something that Docker utilizes. And this is something that we've been providing for a number of years on our platform. In SUSE Linux Enterprise Server 12, or actually in all of our distributions, customers ask us, how do I get the most recent version of this package or this product? And it's not, and we're currently between service pack releases. And I don't want to wait 12 months or 18 months for the next service pack release. So what we've decided to do is we've decided to introduce the concept of modules. And modules give the customers the flexibility to go in and add individual components into their use. And the important thing here is that we're doing this in such a way that we are fully supporting what we release. The important thing to realize is that when we do this in such a way that it does not impact the user space or the application compatibility. We do this in such a way that it doesn't make kernel changes happen. So the modules are there, and you can see a list of some of the modules that we're going to be working on. The modules are there to allow you to take advantage of some of the latest innovations in the open source community, but at the same time, maintain your supportability and your user space. Now here's a little bit of a closer look at the modules and the lifecycle support that we're going to be providing in those modules. The most common things that we hear from customers is, I need the latest version of a compiler, or I need the latest version of a scripting tool. So that's going to be happening in SLES 12. You're going to be getting more frequent updates on a regular basis. You'll get access to things like Python and Ruby and PHP, yearly updates to the compiler, and access to some of the legacy technology that gets patched on a Linux distribution for a number of years as well. Now, I talked a little bit earlier about ButterFS and the fact that it provides snapshot capabilities. And this is one of the ways that we are going and increasing uptime. And the important thing here, when we talk about increasing uptime, we're not talking about eliminating downtime due to crashes, bugs, or problems. We're also talking about reducing the time it takes to do planned and scheduled maintenance. We're talking about making sure that system is available as quickly as possible and available for service as quickly as possible, even during those planned maintenance windows, and then sometimes eliminating those maintenance windows in its entirety. So with ButterFS and some of the other innovations that we've included here that we'll talk about in a few minutes, we're now giving you the ability to do a complete snapshot of the entire system. Now, when we first introduced ButterFS a few releases ago, you were able to do snapshots on particular directories. That was for administrators only. We then made some more flexible changes into our snapper tool and opened it up so that end users could actually do snapshotting of the files and directories that they had access to. But now we're introducing full snapshot support for the file system end-to-end. This allows you to actually apply a service pack and roll it back based on the last known good snapshot. It allows you to upgrade the kernel and roll it back to the latest known good snapshot. And all this is made possible, again, by ButterFS and our snapshot tool called Snapper. The other important thing to realize is that these are not standalone solutions. We've made some huge changes in SUSE Linux Enterprise Server 12 in how the fundamental of the Linux distribution comes together. And that includes changes such as the bootloader and support for things like SystemZ and Wicked to actually get us to the idea, or get us closer to what we refer to as a good state, actually knowing what's running on the system. Another way we're reducing downtime is by introducing kernel live patching. Now, you might have heard earlier in this year, there was a lot of news around a technology that was developed at SUSE Labs called Kgraft. And what this is the ability for SUSE to release to customers who need this capability specific kernel modules, which allow you to apply the kernel modules on a running system. Now, there's some other technology out there that say that you can patch a running kernel, but in some of those other technologies, they actually stop the kernel for a millisecond or two in order to apply the patch. We do this with zero execution interruption, and we do this without stopping the kernel. Now, this is obviously important for mission-critical systems. Obviously, SystemZ fits into that space. And this is going to improve general availability and in some cases eliminate maintenance windows and the need to actually schedule time to take a system down for patching or rebooting. Now, I will tell you that not everything can be fixed with a live kernel patch. Some patches are a little bit more invasive and will require a reboot, but we'll make sure that everybody knows when those are occurring and what those are and when those happen. And I think this is really important for customers to realize that, yes, you can do maintenance and patches and updates. You can roll those back if something goes wrong with ButterFS. You can tie that in with our live patching service that we're going to be offering. And, you know, it's important for us to hear feedback from customers. This is something that we've been working on for a while now. If this is something that you're interested in and this is something that you need on your SystemZ, please send Marcus or I information about that need, and we'll bring this to market as quickly as we possibly can. Again, with SUSE Linux Enterprise Server for SystemZ, we provide our high availability extension. So I just had the pleasure of presenting last week at IBM Enterprise 2014 in Las Vegas. Very similar presentation, great turnout, good questions from the audience. And I did ask a question of the audience, and I said, how many customers are aware that with your SLES for SystemZ subscription, you get access to our high availability extension? And there was only one or two hands that came up in the audience. So this is something that you guys have entitlement to today. And this is something, again, that helps you minimize downtime and provide availability to your customers. Our high availability extension will allow you to fail over a Linux distribution either on physical machines or across virtual machines. It's great for dev and test environments. It's great for helping manage virtual machines that might need to have an eye kept on them outside of the scope of some of the really great tools like that IBM provides, like Parallel Sysplex. This is a free solution included in your subscription, and we do encourage you to take advantage of it. It's an open source technology that we use. It's an open source technology that we contribute back into the community, and it's probably been, I think it's probably one of the easiest high availability solutions to implement. It only takes a few command lines to build a multi-node cluster and have servers join that cluster, and we provide some agents pre-configured to help you along the way of setting your thresholds and your limits. So I encourage you to really take advantage of this solution, use it in your virtual environments, and remember that only you can prevent downtime. We also have an add-on component to our high availability extension. It's called our geo-clustering solution. This is a solution that is an additional cost or an additional subscription. It does provide business continuity anywhere around the world. And the important thing here is if you're failing over on a single machine, you're failing from VM to VM, that works great. If you're failing over from a physical machine to a physical machine within the same data center, that works great. But if you need to have that low latency failover between data centers that are geographically dispersed, you will need to upgrade to our geo-clustering service. So one of the other differentiators SUSE has been taking advantage of for a number of years is providing ease of use. We've been providing our YAST administration tool for a number of years. It was the first fully integrated graphical management tool for a Linux environment. We continue to evolve it. We provided YAST for a number of years with its own scripting language to allow customers and partners to actually build their own modules inside of YAST. Well, the problem was nobody wanted to learn a scripting language just for YAST. So we've listened to customers, and we've now completely rewritten YAST with Ruby. So now if you have Ruby developers in your environment, you can now do additional scripting in YAST to provide YAST modules for maybe your service request process, for maybe your user creation process. You can go in there and provide additional value to your administrators. And this is all in the hopes of providing additional operational efficiency. The same is true with AutoYAST. You can use Ruby scripting to further automate your AutoYAST environment. Another change that we've introduced to help improve operational efficiency is a networking technology called Wicked, and I think we're going to talk a little bit more about that in the upcoming slides. Just double check here. Yes, we will talk about that in the future. We also are improving our installation workflow as well as our unattended upgrade process for our architectures. So again, eliminating downtime, creating operational efficiency, helping you get from one version to the next version, helping you deploy your images faster is really what we focused on for improving operational efficiency. So let's talk a little bit about SystemZ. SystemZ has been a hot topic inside of open source for a number of months. There's actually people that want to boycott SystemZ, and I'll try and give you the best explanation that I can give you as to why SUSE has adopted SystemZ and why there's really nothing wrong with SystemZ except for the fact that we are trying to look a little bit more towards the future. So in and around 1996, Linux adopted SysV Init, which, if anybody's familiar with Unix, is familiar with how SysV Init works. It basically uses a series of scripts to start up the services and the run levels inside of a Linux distribution or a Unix server. But since 1996, a lot of things have changed. systems have gotten more complex. We've introduced not only highly available, highly scalable systems like SystemZ, but we now have Linux running on mobile devices, right? So additional complexity and flexibility has come into there. And Init was getting a little bit too slow to manage some of that change. So what we worked within the community to do is to build an Init replacement. And the goal here is that SystemZ is going to be responsible for all the startup and shutdown of the services inside of the Linux distribution. Now, all this is going to be done via sockets in the dbus. Now, the great thing about not having a dependency on initialization scripts is that we can now stop doing things in sequential order and start doing things without dependency in parallel order. So you're going to notice startup times greatly reduced. The fact that we're doing all this activation via the socket in the dbus actually provides additional value because we now can use that socket information and that dbus information to set control groups based on logins and the customer services that are starting up there. That gives us additional flexibility and security control over what services a customer has. The other thing about the services, the sockets, and the control groups is that we now actually know what's running on a system. Previously, if you were starting something with an init script and that init script failed, you wouldn't know the service was unavailable unless the person who wrote that script actually was doing reporting back and said, this failed. Well, now we can actually reload things because it's all running as a daemon. If something fails to load, it'll automatically reattempt to load it. If something crashes during running, it'll automatically recognize this should be running and it'll restart it. There's no reason to go back in and have to restart services manually. Additional value that SystemZ is going to get you is logging. I asked some folks in the previous presentation how many people put log information into their scripts after a script successfully executes or fails. How many people push that off to a system log? And sadly, nobody raised their hand in this particular session. But now with SystemZ, all the logs can now be centrally located. Now, we wanted to make sure that we didn't, again, like when we did with our first move from the 2.0 kernel to the 3.0 kernel, we wanted to make sure we didn't break ISV application compatibility. And we did maintain that when we went from the 2.0 to the 3.0 kernel. And when we introduced SystemZ, we know there's a lot of dependency from some ISVs on init scripts. Some ISVs may place init scripts into your system in order to start the services that they need to start. So we are providing compatibility with those sys5 init scripts. That's not going to change. So things should work just as they always have, but we are going to be able to take advantage of some of those new capabilities, such as parallelization, control groups, and logging with SystemZ. Now, the people who don't like SystemZ, they have their reasons. Most of them are very comfortable with what is happening with the sys5 init scripts. They like sys5 init. They fear that something like SystemZ is too big and too important. But as we talk about things earlier in our release, in this overview, we talked about things like snapshotting. SystemZ provides huge value in snapshotting because now that everything is based on sockets and the dbus, we know what services are running at any given point in time. So when you snapshot, SystemZ can help bring those things back online the way they were. And this really helps with the overall system snapshot and not just snapshotting directories. So I hope I've won people over. If I misspoke, I apologize. I'm sure Marcus will correct me. But that's why we moved to SystemZ. Now, I want to introduce to you something that we call Wicked. Wicked is one of our attempts. Again, this is something else that came out of the Linux labs at SUSE to help deal with the growing complexity. So I mentioned back in 1996, Linux did the initial adoption of SysV, and now here we are in 2014, and we're introducing SystemZ. Well, in 1996, when you looked at Linux, and you looked at the way networking was, what did we have to contend with? Typically, we had to contend with 1 or 2 cables plugged into an Ethernet port. Times have changed. We now have to deal with FICON. We now have to deal with virtual network controllers. We now have to deal with IPv4 and IPv6, and we have to deal with bonded and unbonded and bridged and controllers, and there's just so much additional complexity now inside of just the network management that we ran into some of the same problems that we ran into with the Init script. They were getting too complex. There was too much nesting going on. Too many dependencies were going on. So at SUSE, we developed this concept called Wicked, and the goal here is to be able to deal with the complexity of these network configurations. Now, this is going to be able to be utilized in both data centers and for end users, and it provides network configuration as a service. And I don't want you guys to think cloud, right? This is not NAS, right? NAS. That's not what this is. When I say network configuration as a service, I mean as a service that's running on the server, right? We don't need to depend now on initialization scripts or config files for the startup and the bonding and the hosting and the configuration of individual NICs. We can now do this through our Wicked solution. Now, Wicked is architecture independent. It will continue to be able to leverage the config files. It is much like SystemZ tied to the dbus, right? So it does provide a daemon and a service that's running. It does provide dbus interfaces for the different architectures or layers of interaction that happens within the configuration. And we really think that as we continue to grow this solution out, that customers are going to find that this, much like SystemZ, is going to be a great benefit. Now, the next thing that we introduced with SLES 12 is a little bit of optimization as it relates to our workflow. And actually, some of this is made possible by technologies like SystemZ and Wicked, right? Because now that we can start services and not have as many dependencies on configuration scripts, we can do some things a little bit different than we've been doing them in the past. Now, typically, when you're doing a Linux installation from an install media, what you do is you start with your installation media and you do the initial setup. And that installation media is going to install a couple gigs worth of data and packages based on what you're actually going to be doing with that server. And that could take, in some cases, 20, 30, 40 minutes, depending on what you've selected and what system you're running. So there's a long wait time in there. After that wait time, you've got to do a reboot. Now that you do a reboot, you've actually got the init scripts and you've got a number of the configuration files that you need to actually go and start up the networking service. Once the networking service is started, you can actually log into SUSE.com and see if there are any updates. And we always provide updates on a regular basis. So when, even with general availability, there might be a patch or two that has to be applied. Well, what if you're 12 months past general availability? I'm sure there's going to be more than a patch or two that need to be applied. So you could be looking at maybe another few hundred megabytes of data that needs to be installed into your system. So what do? You wait. And that data and those bits get installed, and you then need to go and reboot. And then the services can start up, and then you actually have a functioning system. Well, so thanks to some of the changes we've made around Grub2 and SystemZ and Wicked, we're changing the way things are working. You're actually going to now start with your installation media. It's going to immediately start your networking services, which will allow you to register to SUSE.com and then allow you to actually do the installation once with updates. So 2 cycles of waiting for either 20 or 40 minutes at a time, 80 minutes or an hour and a half, whatever it might be in total, is now reduced to a single wait cycle. You then reboot, and your system is ready and live. So again, when we talk about operational efficiency, we're talking about bringing your systems up faster, improving the way your administrators have to deal with networking configuration, improving the way your administrators have to deal with system issues that can now be taken care of with SystemZ. And for our last focus on operational efficiency, we are making significant changes to our customer care center. Our customer care center has been completely redesigned, and with /12, you're going to get access to more information about the systems that you are managing. It'll go and provide you information on your active subscriptions. It'll give you warnings if your subscriptions are going to be expired. You'll have a single dashboard view of not just your subscriptions, but your individual extensions and your service packs and your long-term service pack offerings. And it basically goes and provides you a single pane of glass to administer your subscriptions and your auditing needs for SUSE Linux Enterprise. So I hope you get a chance when you use /12 to go out to our new customer care center and try it out. And please provide us feedback. There's always a button at the top for feedback. So, what's new with SUSE Linux for Enterprise Server on SystemZ? That's actually what you guys came here for. And now what I'm going to do is turn this over to Marcus and let Marcus lead you through some of the advances here. I hope you realize in what I've shared with you over the past 30 minutes or so that there's a lot of changes to Linux in general. But Marcus is going to now dive down a little bit deeper and talk about SystemZ.
Yeah, good morning, good afternoon, everybody. As Patrick has done a very good job to step us through the general changes which happened within SUSE Linux Enterprise Server with the upcoming release 12. This is true for all the systems, for all the architectures, and now we look into what's on the specific part, as you said. It is a more or less high-level glance to certain areas we have done improvements to. So the bulk part of work, actually, which I like to highlight, is the transition from the things Patrick mentioned before, integrating SystemZ into the system, making it compatible to the old Init scripts, introducing a new bootloader, which is capable to do more and exciting things and actually have more choices to boot from, for example, snapshots or other devices which not have been possible. But there are a few which I would like to highlight, and one which is, if we talk about innovation, is the architecture level set. So architecture level set means that in a certain instruction set is chosen to build the whole system, and we did that step now with /12 and chosen the two models which are actually out in the market today, which is the Z196 and the EC12. There's also a reason behind it why we did that. So there's continuous improvement to make the instruction set better to fit workloads, to make them more performant. And there has been a big step and big advancement coming from Z10 type machines to Z196. So there have been a lot of instructions being added, and former type systems didn't actually exploit that in the kernel and also in the user land, which was supplied with the so-called system compiler. So what we did in the past also, we provided compilers which were of a newer version and which were able to be set by specific parameters to produce more optimized code, more targeted for specific processors. So this time, SUSE Linux Enterprise 12 will come with the instruction set to Z196. So we'll run on a Z196, the Z114, and the successor machines, and we will be using the instruction scheduling, which is of big importance to produce optimized code to fit to the EC12. So we're combining both worlds to boost performance. We also have the respective compiler included into the SDK and the system compiler. We will spend a word on that on one of the next slides. One important thing to note is we keep on exploiting the hardware which is mainly out there in the marketplace. So with /11 we have support down to Z9, Z10, Z196, and EC12, and also the business class type of machines. With 12, we settle on the list which we provide here. So the latest versions are supported, and also we still and have included the ZBX support, the BladeSaver extension support, to have full coverage for the IBM Enterprise System. Just a little picking from other areas. So beside these things, if you look at the features which we have in more details in our feature database, and I'm now providing a summary, there are certain areas which we can highlight. It's typically the Rust areas where SystemZ has a very strong, unique selling point. The tools are very well developed, so that issues can be resolved if they occur very quickly. So we have the standalone dumper. We can dump to ZFCP partition out on the storage network, and in other areas where new device drivers and software stacks have been introduced, like for the crypto stack, we have the latest crypto support for the hardware included, as well as the appropriate stack with new codecs and modules. We also continue to include the disk mirroring facility, and I'll share words on one of the following slides. With the new compiler and the binutils, which is the tool chain to get from source code to executable code, we now support the transactional memory support for EC10. In /11, we already had a kernel part implemented, which allowed then new Java versions, and these workloads scale better with that support. And we're hoping to get these improvements also now for EC12 once there is software available which can really exploit it. The good news is, for people who produce their own software, they can start right now, and we work with the vendors to get recertification and rebuild for optimized support on the EC12 hardware there. Also encourage you to ask your vendors when this support will be available. Customer voice count more heavily. Built in with the new tool chain and glibc is a function which is basically a function where the library the code can select the specific functions which are optimized and run better on specific hardware, so that it squeezes out more performance, is less costly with regards to CPU cycles, and can improve performance. Also, I like to mention, as in the past years, we have again KVM for SystemZ included as a technical preview. For those which are not familiar with KVM, it's an abbreviation for the kernel-based virtual machine, which allows using the virtualization capabilities of the underlying hardware to run virtualized guests. Technical preview means the code is there, you can load it, and it comes with some support restrictions. It's not targeted for production use. However, we see that as a great benefit for people who are choosing the right platform for the right workload. And these people very often, due to their background, might come from an x86 or maybe even power background. So they will most likely feel very familiar with that environment using their own tools. So our own developers have quickly adopted and worked with these solutions. So this is something which can really bring people which are not very knowledgeable about the platform and might have some hesitation to enter this place. Once they get a command line and they can use the tools and the commands they're familiar with, and then create virtual guests, they will be probably enthusiastic about the platform, and then also explore the other options which are available. more developed and in production use out there. So it's actually something we consider to lower the barrier for people to get known to the mainframe and get familiar with the mainframe and then get curious and get started and to exploit it. So a little bit more information, as I already said, the cryptographic acceleration support, it now includes the PCK11 support and handling stack. Based on customer request, as the installation of cryptographic stack and the device drivers and things have been a bit tricky in the past, we have created a special installation pattern. So if you select this, you get all the required packages and RPMs installed to get it up and running. This includes also the new hardware support for stronger encryption and facilities to exploit the CPACF functions. Support transparent large pages. This is an implementation where large memory chunks can now be handled more efficiently. We're seeing that guests increase in size, specifically on the ZVM. ZVM 6.3 now allows 1 terabyte guest, so that's the perfect timing to get more or bigger size virtual machines with a little bit more efficiency. IP version 6 enablement, the virtual IP address migration is now available also for the IP version 6 version. Probably most of the users will still run IP version 4, maybe also protected networks, but here's the option actually to extend to IP version 6 type systems. This one with real-time enhancement, it's a short-term but longer description. It's actually about having multiple volumes, and we're speaking more in 50 to 100 volumes working in parallel and mirroring the information for redundancy. So in the past, it was difficult if one of the storage units had a timeout to cope with that timeout. So the solution buffers to a certain extent these timeouts and will be able to synchronize to it. It's in use in production use in /12. It's also available with, in /11. It will be also provided with /12. Channel path ID, physical channel path ID mapping to channel path ID mapping is nice to have if you want to drill down to an arrow due to all these abstraction layers to really drill down to the root problem. So that counts into the Rust area as well as the concurrent flash MCL updates, so you can refresh the microcode on the flash disk without interrupting operation. And we already heard from Patrick in these areas and around that areas to improve operational efficiency regarding system boot up or installation. We've done minor tweaks in the areas where, for example, large amounts of disk can now be better handled as the UI is restructured and the workflow is improved. Also, we picked up from the S390 tools that the DASD format improvement in speed. So in the past, we already did formatting in parallel, but now the single device speed up will improve and get you faster to your goal. The NetISOV pass for 11 was only available to have one channel configured between, or passes configured between VM guests. Now you can have multiple for more redundancy or for more throughput or for whatever purpose you deem appropriate. Query author table gets you more data to analyze what's going on your OSA card related to the IP connections going out. And there's an optimized compression library, which is used for several purposes. It comes with the system. It's used for compressing or decompressing the RPMs in the system, the Java classes, and also for backups and even PDF generation. So that uses some of the newer instructions if they are present and can have a significant speed up. So with that, getting to one of the panels, this is not to take you through all these these things, but it's more about to encourage you. If you are not present on that slide and you're approached by one of our people to be a reference, it's good to be a reference because then other people know what you're doing. It's really interesting to see in how many ways actually Linux is exploited to have workloads being consolidated. When you look at the statistics, you see that the main workloads are databases, are web application serving, and then it ripples down a lot. However, there are very often very nice workloads where people have brought to the mainframe, and exchanging these workloads among people is really something which can help all the community around Linux on the mainframe. So with that, let me do a first summary. We've been working with IBM for a long time, and we're continuing the partnership to provide the next generation of enterprise operating system to you. It has an extended roadmap now. We will continue the partnership and working closely together with IBM to bring the best Linux to you in the world. We continue to exploit SystemZ Enterprise, and we're looking forward to see what's coming up within the next years. We will be including the tools to exploit the architecture and to promote its unique selling points. And what's really nice also to see, we have a growing worldwide customer base, not really fast, but it's continuously growing, and that's thanks to you all out there worldwide. With that, I'd like you to point you to some resources which are out there. These are links to our web pages where you can learn more about Linux and SystemZ. For those who want to give it a start or will recommend it to people, the starter system makes deployment very easily without leaving the system boundaries. And of course, we have a download area where you can download SUSE Linux for SystemZ. And if that has made you more appetite to drill down more, there are lots of changes coming up. It will be very interesting to hear your feedback. There are new exciting features included in that. They require also some learning and exchange. And with SUSECon coming up in November, we will basically all be there. So it's a nice event. We've been there the last years, and what's really nice there, you can have direct exchange with most of the SUSE people. So from the product managers to the alliance people to the developers to the ISV guys, most of the people are there. They are accessible for talking during the sessions, and of course the session schedule is filled up with technical details, not only for the mainframe, but covering all the things SUSE can offer to you, and it's a really great place to exchange. So with that, I pass this back to Tammy, and I think we open it up for questions.
Yeah, so I'd like to squeeze a few questions in the remaining minutes that we have. Again, if you have a question, you can use the Q&A panel on the right side of your screen to send it in. And if we don't get to it because of time, we will get back to you via email. First question, I heard that you're moving to a new bootloader, Grub 2. How does that change the IPL process?
So the new bootloader is basically then requires a two-stage approach. In former times, we had so-called ZIPL, which was easily to configure and would read directly blocks from a booting device. On the other side, Grub 2 is capable to really read file systems. Now, if we want to combine and explore and exploit the capabilities like things we do with ButterFS for system snapshotting, that would have required to bring in a lot of code into Grub 2. We thought of another way, and that the design we choose was actually, or is actually using established technologies. What we will be doing, we have a specific boot partition where ZIPL boots on KXX kernel, which we also use for creating dumps and things like that. And it loads a thing which is called grub2emo. It's an emulation layer, which then serves to really start the second stage and then have a full system up and running, spawns into to the system, brings in the kernel we want to have, and then we will be capable to access a variety of file systems, a variety of devices out there, and also be able to boot from snapshots. So if you need more information, I can send you a link to a presentation which has been done in a chair at Vicksburg from our project manager, Krumreich. If you're interested, shoot me an email. You got my email address up there on the web. Hope that satisfies the question.
I need to upgrade from SUSE Linux Enterprise Server for SystemZ 11 to 12. What's the easiest way, and can I perform an unattended migration?
So upgrading, so you have to distinguish two cases. Unattended migration means I don't have to do a manual interaction, and the other thing people often think of, can I put in patches and it will be on the new system without disturbing operations? So due to the massive, so what we will be supporting is unattended migration from SUSE Linux Enterprise 11 SP3 to 12 for the upcoming SUSE 11 Enterprise Service Pack 4 to 12, and from Service Pack 4.11 to SUSE Linux Enterprise 12 SP1. So that's out in the future, but that's the planned migration passes we are planning today to be safe for the future. The actual migration requires that we boot or start a /12 system. That would mean we bring down the /11 system, we boot into a /12 system, then we do the update on disks, and it will receive all the channels required and the connections, and then we need to reboot in the /12 system. So changing or upgrading or migrating from 11 to 12 will bring down the system, but can be done in an automated way.
All right, one last question. What version of GCC is required to support Z196, Z EC12?
We have included GCC 2.8 as far as I remember correctly. I can review that, but I think that's the version we have there, and it includes the support for the questioned architectures.
Great, super. Well, looking at the clock, I think we should try and wrap it up. So thank you, gentlemen, for sharing your expertise with us today. Just a quick note that we will be sending out a link early next week to a recording of today's presentation to everyone who's on the call, as well as to anyone who registered for the event but for whatever reason couldn't make it. So that concludes our webinar. I want to thank everyone for attending, and have a great day.